Hello and welcome to PCMINR.com, and you're watching this video on relative velocity in 2 dimensions by Sonal Gupta. So let's talk about relative velocity in 2 dimensions. Now see, if we just take here, say Sam is coming across the road from here and Lena is going towards the same point from this direction, as you can see here. So if you look at them, Sam is going this side and Lena is going this side, but that is individually with respect to the ground. But what about their velocities with respect to each other? Like if you look at Sam from Lena's perspective, and suppose the velocity of Sam is Vs is 3 meters per second with respect to the ground, and velocity of Lena is say 4 meters per second with respect to the ground. But do you think that the velocities are going to be same with respect to each other? No. As we know about the concept of relative velocity, so we know that relative to each other, they are not going to have the same velocities what they have with respect to the ground. So let's say that according to Lena, Sam is coming towards right. No, he's not just coming towards right, because Lena is going forward and these trees alongside the road, they are moving backward. So if we say VL, the velocity of Lena is 4 meters per second upwards, then velocity of the trees is VL going downwards, because they'll also move back with the same velocity as Lena is moving forward, because that is our perception. We always see that the things are moving backward, right? That is how it appears to us on the roadside. And so here in this picture you can see that the trees are going down, so Lena is going up, and Sam is though coming towards right, but for Lena, he's not just coming to right, he's also coming a little down. So we would look at this with a view that Sam is going like this, and Lena, we would say the velocity of the trees appear to it along this direction. So for Lena, this guy Sam, he appears to be coming along this direction. Right? So this is the relative velocity of Sam with respect to Lena. So if we look at it, we find that Vs, which was 3 meters per second towards right, and velocity of Lena individually was 4 meters per second towards left, but we have taken the negative side of it, that's downwards, I'll write as -4, and VSL, that gives me the velocity of Sam with respect to Lena, because that is with perspective of Lena, because he's not just going to the right, he's also coming towards him, towards her, so because, or she's approaching towards him. So this is how we look at it, that Sam appears to be coming from this point towards Lena, right? And so we get the relative velocity along the hypotenuse. If you look at it, this is a right angle triangle, so I'll mark the points as A, B and C, and in my right angle triangle I have AC as the hypotenuse. So AC square by Pythagoras theorem is equal to AB square plus BC square. Therefore the relative velocity of Sam with respect to Lena is not 3, but it's going to be 9 plus 16, that gives me 25, and therefore AC alone without the root is 5. So the velocity of Sam with respect to Lena is 5 meters per second. That's the relative velocity you find out in 2 dimensions. And we can look at, we can just see a numerical here, how we apply this in our life. So let's look at this problem. Suppose you're riding on a bike at say 6 meters per second towards the right, and how would you hold the umbrella if it is raining and you want to protect yourself? Please don't think that you're going to hold it like vertically upwards, because to protect from rain you need to understand the relative velocity of rain with respect to you. So it's though falling vertically down with respect to the ground, but with respect to your velocity it's not going to be down, because if you just look at it, the moment say the rain is falling down with a velocity of 4 meters per second, and it falls down 4 meters downward, then you have in 1 second, if it falls down, you have reached here. So the raindrop, instead of falling down vertically, it's going to fall on you like this at an angle. So therefore it's not that easy to just find out that you hold the umbrella in a vertical direction. So how are we going to hold the umbrella? So we say that you are going towards right, and the rain, actual velocity of the rain is vertically downwards, but the velocity of rain will be relative to you. So we will not take the case of velocity going to be right. We have to take it because we want them in the same order. So we will take that rain is coming towards you, right, with a velocity of 6 meters per second. So we won't say that you are moving 6 meters towards right, but rain is moving towards you because according to you it's moving towards you. So at 6 meters per second, whatever velocity with which you are moving towards right, the rain appears to be approaching towards you at the same velocity, and this is 4 meters per second downwards. So these are in the same order, and therefore the relative velocity of the rain is going to be along this direction because it appears to be coming towards you at some angle. And so say this is an angle alpha, then what is the angle which this rain is making with respect to you? So that you can calculate by applying right hand trigonometric rules. So we have tan of alpha is equal to perpendicular upon base. So height here is 6 upon base here is 4, and so we get this as 3 upon 2 meters, 3 upon 2, and therefore what is alpha? It's going to be tan inverse of 3 upon 2. Tan inverse, or we also write as arc tan 3 by 2. So when you look at the table, you find the value. So we roughly get this angle to be 56 degrees when you look at the table. So that means you will not hold the umbrella vertically upwards, but you will hold the umbrella at 56 degrees with the vertical. So we'll write 56 degrees with the vertical, and you can see here that the rain is coming towards you along this direction, and you'll hold the umbrella along this direction at an angle alpha, which is 56 degrees with the vertical. I hope you understood this problem. And if you want to find the relative velocity, the magnitude of the relative velocity, as it's just the hypotenuse, so we can see, so we have to take the direction of rain and both towards this side. So because it's just the hypotenuse, we say we can simply apply the Pythagoras theorem and find out the value, because the rain is falling down at 4 and this is moving at 6 meters per second. So the length of the hypotenuse gives the magnitude of the relative velocity of rain with respect to the biker, or that's u. So we have it as square root of, by Pythagoras theorem, it's going to be 16 plus 36. So we just get square root of 52, which on solving will give you 7.2 meters per second. So the relative velocity of rain is pretty fast. That will appear to you. And so this is how we can solve the relative velocity problems of the rain and umbrella problems based on the formula for relative velocity. I hope that is clear to you. Thank you for watching. If you like the video, please follow us on Instagram and Facebook at PCMINR.com. Thank you.